So our school, Mandurama Public School, we're in a very small school in central west New South Wales. Currently we have 5 students in the years 4 and year 6. We all learn in the same classroom. That's done through really careful planning. So this STEM initiative at our school, it actually began with our parents. We asked them what they'd like to see at the school, and overwhelmingly they wanted our kids to grow their own vegetables and to then prepare them and eat them. So it was a nutrition, it was a learning to grow things, it was a real event that they wanted to happen.
So when implementing this garden project, I first took it as a bit of a design brief, and for me that was about making sure it would survive any droughts and make sure that our growing season over summer is still able to be utilised. So that's how the idea of the wicking garden bed came up.
This is a wicking bed. It has plastic here to hold the rocks so they can soak up the water for the plants. And this is a non-wicking bed. These plants usually die because it doesn't have the needs it needs.
It has rocks in it, but it doesn't have anything else.
Our wicking garden bed has thrived. It's got some great things happening. Our non-wicking bed has not. So things have died over the summer, and we really talked to the kids about why that might be. And one of the reasons they thought was because the wicking bed holds moisture better than the non-wicking bed.
We were able to design an experiment where the kids were able to test for measuring the moisture in the soil. The digital technology that we were able to integrate were the microbits. The microbit is sending the current from the battery around this wire to this nail. It's measuring how well it's transmitting through the patch of dirt because water conducts electricity. So that one is
292.
292. So what we need to do now is get our clipboard and write down this number, and then we'll go do the same thing on the self-watering garden bed and see if there's a difference in the number.
The measurements we took were to measure the dryness or wetness of the soil. We found out that the low numbers meant that the soil was drier. We took the measurements and put it into the table to see which one was the highest and which one was the lowest.
Having that data meant that we could ask the students how that data could be used, and they were able to identify ways in which a garden could sense that it was too dry and then needed to be watered, and they had a go at designing different methods of watering the garden mechanically using these sensors.
So when we started this project, we had students from kindergarten through to year 6. We started from a content base and look at what the younger students need, look at what the older students need. We can really differentiate using that scientific thinking. So when our younger student is recording, she's drawing, we're writing a sentence together, doing some labelling and supporting her to do that, through to the older students actually using Excel to record their data and make some generalisations.
The thing I really love about STEM learning and project-based learning is watching the kids come up with their own independent thinking. They're coming up with ideas themselves, they're finding solutions to problems. You know, they can really start to explain their thinking behind their solutions.
It's impacted the school because it's everyone's business, and we know everybody is involved with this project when the parents come up in the summer holidays and are watering the gardens with the kids. So it belongs to all of us. The kids are incredibly engaged with it. We're really embedding it into what we do in all of our learning areas.